Hopefully you had some success with the remove last method. In this video, we're going to go over one possible solution. So I'm inside my index.js file. I'm at my remove first method, and underneath this thing, we will define the new method remove last, like so. All right, so the first thing we're going to do here is to think about some of the edge cases that we have to deal with the given solution that I laid out in the last video. So I want to first think about what we should be doing if the list is completely empty. So if the list is empty, I don't want to attempt to get a reference to the first node or the second one. I don't want to try to iterate through anything, nothing like that. So as the very first operation I'm going to do, I'm going to check to see if there is not a head node. So if there's not a head node, that must mean that our list is empty, and I should just immediately return without attempting to do anything at all. So let's save this, and if we flip on over to our test now, you'll see immediately that one of the tests is now passing. So here's remove last, and our goal was to make sure that if the list is empty, we shouldn't crash and essentially nothing should happen at all. So with that simple if statement, we've satisfied one check right here. Now the next thing we're going to do is consider the case in which the list has a length of 1. So there's only one node. If there's only one node, back over here, so if there's only one node, then I don't really need to start up my algorithm at all. I don't need to get a reference to the second node. I don't need to try to iterate through anything here. All I really want to do in that case is remove the last node, which in this case would also be the first one. So in that case, I would want to delete the only node that we have. And remember, we can delete that node by setting this.head equal to null. And then we would want to immediately return from the function. So to check to see if we have a length of 1, we could call the size method that we had previously defined, but another easy way of doing it that doesn't rely upon that method would be to look at the head node. So if there is not a node at this.head.next. So this right here, this.head.next, would be a reference to our second node. And then we're saying if there is not some value defined there. So if there's not some second node there, that means that we have a list of length 1, and we should remove the head and then immediately return from this function and not attempt to do anything else. So I could say this.head equals null, and then we will immediately return. Now let's check our tests. And back over here, we now have our second test passing. Very good. So now we're going to start to write the actual algorithm that we care about. So this is the algorithm where we are going to set up these two variables right here. Previous is going to refer to the very first node to start. Node will refer to the second one, and then we will iterate through our linked list. And for each iteration step, we will point these two temporary variables at the next node along the chain. And then as soon as we find a node that has a next value of null, that means that we need to remove that current node. So let's give this a shot. We'll first start off by getting a reference to the first node and the second one. So we'll say let previous equals this.head and let node equals this.head.next. Now, as long as node.next exists, so remember that means that there is some next value after node right here, there's some additional element that we need to iterate through, then we'll update the value of previous to be the current node, and then node will be set to node.next. Now I just kind of went through that very quickly, so let's look back at the diagram and explain exactly what this while loop right here is doing. So again, we initialize previous and node. We've said that like 3 or 4 times now at this point. We know that very well. So back over here, we check to see if node.next is defined. So is node.next defined? Well, in this case, yes, it is, right here. So that means we're going to enter the body of the while loop. The first thing we do is to update the value of previous to node. So when that body of the for loop, or excuse me, the while loop runs the first time, or that first line of code, we will take previous and we will tell it to look at the same node that node is. And then we update the reference node to look at the next node. So now node is going to be looking at the next node. We then re-enter the for loop, or excuse me, I keep saying for loop, I mean to say while loop. So we re-enter the while loop and we check to see if node.next exists. So in this case, node.next does not exist, which means we have hit the end of our chain. And so we need to make sure that we now delete this last node. So like we said several times, to delete that last node, we can go back to the previous node and update its next property to simply point at null rather than its current value. So after the while loop, we'll say previous.next equals null. Notice how we don't really have any if statement here or anything that specifically says, hey, look, we're at the end of the chain. We are using this while loop right here to just keep on iterating through and through and through the linked list until there's no longer a next node. And as soon as this situation right here, or this expression right here evaluates to a falsy value or is null, then that means we are at the end of the list, and we can just very easily say previous.next is null to remove that last element. All right, let's check our test now and see how we're doing. So back at the terminal, all of our tests are now passing. Awesome. Okay, so this has been our remove last method. Let's now continue into the next video where we're going to do one more very, very similar method. Oops, maybe not. Insert last. So we need to insert a node at the last or the end of the chain. So let's take care of that one in the next video.